Welcome back to Engineers Workshop. It is December 1st. I hope all of you had a great Thanksgiving. I know we did. And yesterday, November 30th, was the day. This is the video that you've been waiting for. I know this is the one that I've been waiting for. Back at the end of August, I purchased my first vertical mill. And November 30th, so you're talking 4 months later, that was finally delivered. Of course, on the rainiest day out of 10. We had a 10-day stretch of beautiful, clear, warm, dry days. Then the skies opened up and it poured, and that was the day that the machine came. But I'm glad it's here. And before I do a little bit of a walk around, or rather let's call it a spin around on the machine, let me show you a little bit of what we went through just getting it unloaded and into the building. I had about a half hour's notice from the driver when he would be arriving, and to my surprise, he did make an attempt to plastic wrap the machine. This wasn't like a shrink wrap or anything. It was just individual, like long continuous garbage bags wrapped around it. I don't know, they probably trapped as much water as they prevented from getting on the machine. The second part of the load, the green containers, are some military item for Langley Air Force Base. So we felt the best way to unload this was to decouple and then come at the machine from the front. This was what the driver also did up in Bay City, Michigan, when he loaded it. We had pretty open access to the front of this, and we used 2-inch nylon strap under, I guess what you would call the chin of the machine. There's actually a lip cast in there to prevent the rope or the straps from sliding forward. They didn't have straps in 1964, so the manual talks about loading it using good quality 1.5-inch manila rope. Mike Beck has a number of good-sized Heister lifts, and at least half of them are working at any given time. So this is an 8,000-pound capacity lift with 4-foot forks. We did have an extender on the forks and used the central, it's about a 4-inch square HSS tube on the fork extenders to get us the additional reach to get over to that collar and pull this off the truck. I'm just trying to keep it steady so it doesn't swing back and bang against the mast of the forklift. Not that, I'm going to stop a 5,000-pound machine if it starts swinging, but trying to very carefully remove it from the top deck of the trailer and get it down to where he can, get it closer to the ground. Then I need to go and get the tractor with the solid wheel yellow cart for the second short journey over to the property. The transport cart I had brought over the day before, and my plan was to put it on actually crosswise. I had fears of this thing sinking into the ground, and since it is longer than it is wide, I felt that the tendency would be to sink to one side or the other, and the mill, the foot is longer in the front to back direction. So I didn't think that there would be any issues putting it crosswise on the cart, and then I'll throw a strap over top of it and prevent it from tipping from side to side, which is actually the end-to-end direction on the transport cart. We spent a good amount of time unwrapping the machine. All of the bags were kind of tied end to end and crisscrossing over top and underneath one another. It was hard to determine where to even start. Probably should have just got a utility knife and slit them all up one side. But as we were, taking these off, there'd be a, quart of water that would dump out from here and there, and everything was wet. It didn't seem to, like, we didn't have puddles of water to deal with on the machine, but the electrical panel door right there, when I opened that, all of the relays and starters had a lot of condensation and droplets of water on them.
How long a shaft did you put a keyway in?
It's got 18 inches of travel. But I mean, you could put it.
18 inches?
It's got 18 inches of horizontal travel.
Okay.
I mean, you could index it over. You could run the shaft outside and step it over, put it in V blocks. My intention was to get it all the way to the end of travel of the trolley beam, but I didn't make enough clearance next to the resaw. I had to move the upper slide, so in this shot it's about 3 feet from where it finally ends up. Kearney and Trecker, Model 2D. It's interesting that the door says number 2. It does say Rotary Head Milling Machine, but nowhere on the machine does it say 2D. Even the name badge says Model D. Now, according to the Kearney and Trecker serial number database at vintagemachinery.org, this machine is in lot number 9480, and lot number 9480 was 12 machines completed in April of 1964. So this is 5 of 12 at the time. It's interesting because I was completed in March of 1964. So it's almost like this machine was made for me. It's actually probably a little bit older. I don't know how long it takes to complete a lot of machines, but I was born in March and this lot was completed in April, so very, very close timing there on the age of the machine. This is my new to me Kearney and Trecker Model D or Model 2D Rotary Head Mill. And on the surface it looks basically just like a vertical mill, but it is a bit of a specialty item. This mill was designed specifically for tool and die industry for mold making. And multi-cavity molds, either injection molds or die casting molds, where you had to duplicate geometry in 3D over multiple cavities. This machine has a couple of extra axes to help you do that. This is all pre-CNC. I believe this mill was made probably late 40s through the, I'd say, 60s. Just give you a little bit of a 360-degree view here. Very stout machine. So it is basically a knee-type mill. It has a single elevating screw. This is the Z-axis, and it does have a power knee, which I'm very thankful for because I was cranking on that, and it's a bear to get this thing to crank up. But one of the features I liked about this particular mill, and this goes back to Joe Fry describing a brand new one that he bought, is the ways supporting the table are longer than the table. So the table is fully supported along its entire travel, unlike a Bridgeport, which overhangs at either end. It's about 16 by 30 inch table. We have 12 inches of Y-axis travel, which is manual only. We have 18 inches of X-axis travel, which is power. And then we have the power knee, but it's not something that you can have feed. It's just rapid up and down. But there's kickouts on the X-axis travel, and tucked down on the lower right corner are the speed ranges for the X-axis travel. There is a cover plate here, which if you remove it, exposes the gear set. And there are auxiliary drives that bolt on to this, which through a spline shaft come over and drive a rotary table. So you can do, compound axis milling driven off the table to do milled threads and other cool features. But the really neat feature about this mill is in the head. Let me get a little closer here. Right now, the axis of the spindle is centered about this rotary axis. The rotary axis, you can see here, rotates the entire spindle assembly, which when it's centered up doesn't do anything. But when you offset the spindle, which you do on this crank, this offsets the spindle axis up to 4 inches from the center axis of the bearing. And once you do that and you rotate the head, you're now milling a circle, a very precise circle. And this is also, this axis has a power feed. The power feed for the rotary axis is mounted on the side of the mill with a shaft coming up, driving a counter shaft all the way up into the head of the mill itself. And I think there's 8 rotational speeds, which through a bunch of math you could figure out what your actual cutting surface speed is to power the rotary axis. The quill also has 3 inches of travel, which is a power feed. Now, one thing it does not have is it does not have the drill press style actuator for the Quill Travel. But there's your Quill Travel, and let's see if I get this guy cranked back over here. Here is your power up and down in your 4 different speeds for the quill up and down, both power up and power down. Everything has verniers in thousandths. I don't know if you can see this, but if you want to zoom in real close to the vernier on the head, these divisions, these degree divisions, they're a good 1/8 inch apart, so you can get very precise settings on the axis of the head. And in addition, the wheel accepts index plates, and I'm sure that there's a Kearney Trecker. If you had a Kearney Trecker rotary table, for one of the size models, the index plates would be interchangeable onto this machine for setting up different index hole patterns. So this thing can do bolt circles just with the axes available in the head, up to an 8 inch bolt pattern. The previous owner had a very basic DRO and Analam 2-axis DRO, which I just powered up, and thankfully it works. This thing was soaking wet from the trip, and I'm still drying it out, but super excited. Got a lot of prep work to do to get this thing tucked away for the winter, but I also want to be able to use it. So I'm going to be coming out with some first chips videos and some little projects to get familiar with it, and we're really going to have a lot of fun with this machine in the future. I certainly hope you enjoyed that. I know I'm looking forward to getting this machine tucked in for the winter. One of the things I have to do, because this building is just open and unheated, I have to keep rust off of the ways and everything that's not painted. So I've got a fairly innovative way, I think, of doing that. I'll share with you in an upcoming video to keep the machine warmer than the ambient temperature. And please share, like, and subscribe to Engineers Workshop, and we'll bring you some machining content in upcoming videos. Thanks again.